Okay, geographers and others, biologists and the like, who are interested in learning how to do this stuff, I'm going to show you today how to take GPS data recorded out in the field. So you're out working, you're recording something. I'm going to show you how to take those data, turn them into something that can be used in GIS software, which can then be mapped, analyzed, studied, and all of that. And it's not that hard to do, but there's a little bit of work that needs to be done here. And there's some tricks that I'm going to point out that I learned the hard way. Hopefully it'll make your life easier, me pointing this stuff out to you. And so to demonstrate this, I've got this on the right here, this PDF that has some data. This was produced by some AVC students who are looking at studying illegal dumping in the Antelope Valley. Don't know if you're watching this and you're from here, you get it, right? We have beautiful scenic desert vistas, complete with couches and mattresses and stuff, just dumped wherever. It's almost like people think the desert it's empty, right? Put some stuff in it. That's kind of the vibe that takes place. So these students went out, they recorded GPS based coordinates for individual pieces of trash. So we can see here the description: metal sheet, couch, full-size mattress, body pillow. That's I don't know why that's the grossest thing on here. I mean, red padded mat is that's mysterious, but there's something about a body pillow down in the desert that is gross. But so there you go. That's the stuff that was out there somewhere in space. And then we have over here in this location column, this is UTM, Universal Transverse Mercator data, these coordinates here. And this was something with these students, and I have a video showing how to set your GPS up for UTM. But I told them to use this coordinate system. I think it's far superior to latitude and longitude. It's just easier to use either in recording data or finding stuff out in the field from a map or whatever. So that's what we have here. Okay. And these are the two key things: what it is and where it is. And then there's this other stuff, the time at which this waypoint here was recorded. This would be, I assume, that's the number that was in the little GPS receiver itself. So it just automatically made it waypoint 009, 010, and so on. Distance, elevation, some of this stuff, it might be important. It might not be. It's all depends on what you're trying to do with this stuff, right? But here's the deal. This, as it stands, it's not going to work in GIS. I mean, it's great. It's thorough. We know exactly what's going on. We know where it's located and all that. But this, while it works for humans to look at and make sense of, with computers, it's not quite the same deal. The computer is stupid. Not to insult it. Maybe not stupid. That's mean. It's not thinking, right? It's not intelligent. So we have to be very straightforward with this stuff. Okay, so two things here. Number one, we can't have this in PDF form, which is fine. We'll fix that. And number two, we're going to make this as streamlined and simple as possible in order to make it work in GIS. All right, that's the goal. So I have Excel opened up here. And really, you can do this in any spreadsheet type program. I use Excel because that's what I've got here. It's what I'm used to working with. But like Google, Sheets, you can do this in there. Whatever. I think it's with Apple, it's numbers or something. I mean, there's all sorts of stuff. As long as you've got something like this here, this spreadsheet software, you should be able to make it work. And I'll point out how to export this stuff when we're done, or how to save it, what file type to save it as, to ensure that it works with something like ArcGIS. All right. Now with Excel, Excel's a great program in that you can do so much in terms of the actual math going on in here to the numbers themselves. And you also have formatting options and things like that. And you can color code stuff and merge cells and have these titles and things like that that look really good. We're not going to do any of that. We're going to make this as simple as possible. Okay, so to start with, in this first row, so row 1 here, so the rows are going horizontally, right? This direction, so 1, 2, 3, 4, 5, those are the rows. And then the columns are A, B, C, D, all right? That's how we go down vertically here. So when we're looking at all of this right there, that would be a column. This way right here, that would be a row. You dig? All right. So with this first row, this is going to have the headings for our different columns. Okay, so much like over here, we have description, time, and so on. Those are the headings there. It's not the actual data, right? It's telling us what the different data actually mean. That's what we're going to do here. Okay, so description, it's fine to have something like that. The problem, though, is that we want to keep it under 10 letters or characters or whatever. Okay, which description, I'm pretty sure, might be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Look at that. The only reason I knew that is because usually when I use a word like description, it says descriptio, which is fun, but just be prepared. Things will get lopped off in here, okay? So, I mean, if you want to do it, go ahead. In fact, I'm going to bother with capitals here. Let's just, in fact, I'll try description. We'll see what it looks like. We'll experiment with that, all right? Now this time, waypoint, entry, stuff like that. I tell you what, I'm going to skip time. For me, I don't think that's relevant to the study. I could be wrong. So if you're doing something and you need the time, of course, put that in there, right? I'm just going to try to do this as simple as possible. But honestly, you can add whatever you want in here. The trick, though, is that with your heading labels in here, keep them short, simple, avoid spaces. You also can't start it with a number at all. That screws stuff up. So you want text and you want simple stuff, okay? So like where it says waypoint entry as 2 words, I wouldn't want to use 2 words because that's going to freak the computer out when we start to try to analyze it. So if I just put waypoint, fantastic, that one will work. Distance, elevation, I'm going to skip that for now. Now this location one, though, that's important. But what we need to do is we need to break this apart, okay? Because with this, we have an easting, that's that first number, the 0389857 right there. That's our easting, and this 3 million number, that's our northing for UTM. Okay, much like latitude and longitude and all that. You have your latitude value and your longitude value, and where these things intersect, that's where you are, right? Or that's where the thing is you're getting to or whatever. Same deal here. Wherever you're easting and northing, these numbers intersect. It's just, it's an XY axis kind of grid thing, right? Wherever those 2 values intersect, that's the location. That's where this metal sheet is located, right? Just like this one here is where this couch is located and so on. But what we need to do is we need to separate the easting from the northing, all right? And this 11S and UTM in there, that's kind of valuable, kind of not for what we're doing. So it's zone 11 is what we're looking at. The letter we can ignore. That's more helpful for like the GPS itself. But the number 11, if we wanted to make this complete and thorough, we could do something like zone in here, right? And we could put, 11 as we're going down, and if it changed, we could have something different, right? We'll do zone just to make it simple. And then we're going to do easting and northing, okay? So let's do this first one. in here. So and see it says Descriptio, but it's just hidden right there. We're gonna type metal sheet. Okay, it was waypoint 009. It does that. We can. It kind of doesn't matter. It's in there, but I can. Let's see. We want text. If I do that, let me try that again. There we go. Zone 11. Okay, our easting is that, and we don't need the 0. I'm gonna leave it off because it's just kind of like a space holder in there. Okay, it's 389,857 meters east is how we read that. The northing is 3,833,956 meters north. I'm assuming I'm reading the right one and writing it there. If I made a mistake in there, it's not, you're not supposed to make a mistake. I made a mistake, right? But that should correspond to what I got there. And of course, you want to double check that stuff. And just to make sure it's all, like, well, just to test it, let's do the couch. Let's do that. It's still, well, I'm not going to get hung up on it because I don't ultimately care. 389,866 and 3833955. Okay, we'll just do these and we'll test this. So right here, this is an ugly spreadsheet compared to this, and you might be tempted to change the font and make something bold or do whatever. Don't do it. Okay, this is what we want. We want this simple thing right here. Okay, and then once you've, like, as you're working, you should save this as you go in case something crashes, of course. But once you're ready to go, and let's just put it here. Get into more save options. Microsoft like made this so easy that it's actually a huge pain. Let me get in here. Here we go. We want to see something like this. So you're not in documents. Give me a. All right, we're in the desktop. Fantastic. Okay, I'm gonna call this. Let's just call it trash because that's what it is. To save this, if you have the save type here, you can, I'm pretty sure this modern version, I say modern, this was like 2007 when they made the switch, but the 4-letter XLSX extension for modern Office files there, I think that works. I'm pretty sure that works. I'm not going to use it. The old one definitely works, so where it's just .xls. So, it was 2003, not even 2000. See, that's how old it is. Here's the deal. With ArcGIS, with this software, it's incredibly expensive. It's difficult to get access to. It takes a lot of training to work with it. It's really, it's the best that's out there. It can't handle this kind of, it's garbage when it comes to working with other stuff. I think some of that is deliberate, but it was only, somewhat recently that you could start actually using Excel files with GIS stuff. So this is why we're keeping it as simple as possible. To use modern computing methods and all that and spreadsheet stuff just doesn't work. Does not work. So to ensure it's as simple as can be, what I'm actually going to do is I'm going to save it as this CSV, okay, comma separated values. And when I do this, it's saving all of this stuff, but it's stored in a different way, effectively. Okay, that's the idea right here. So it's just, and here, let's do it. Let's see what happens here. Let's save. Looks okay. I'm going to close this. Oh, it didn't even warn it. Usually, oh, that's good. Maybe that's an update. Usually when I do something like this, and see, it's right here, down here, trash.csv, it'll warn you. It'll say, whoa, you sure you want to save it like this? Because this sucks. And you have to keep saying, yes, I want to save it like this because this is what we want. And if I open it up, it should open right back up in Excel. It's going to look this way. You see how I changed it with that waypoint, where I changed it to text so I could have the 009. That's gone. Don't worry about it. It doesn't really matter for this in here. We could still figure that out. And there are ways around it if we're worried. Okay, but that looks good. You want to save your changes, don't save, we're good. Okay, now what I'm going to do, I have ArcMap, this GIS software, opened up. And I know for some of you who are watching this, like the biology and different other science students, the STEM club folks and all of that at AVC who might have been pointed this way, you may have not done anything with ArcGIS, ArcMap, whatever. And that's, I mean, to be perfectly honest, that's your loss. That's because you made the horrible choice to take biology classes and chemistry classes and stuff like that, and you're not over here playing with the geographers. This is the fun stuff that we do. Yeah, I'm talking to you. So I'm still going to go through it so you can see what the end goal is. And this also, if you are working with GIS software, you get a sense of how to do this, how to bring this in here. Okay, that's the idea. So I want to add this table, and let's see. I'll try. I think I got beautiful. Got the desktop. You see my trash.csv. It's right there. I'm going to hit add. And the first thing I want to do is right click and open that up. And there we go. This is good. I see what's going. Oh, look, it didn't even make it descriptio. That worked. Okay, that's good. Fantastic. Oh, I know I didn't do that. Okay, that's a different file type. It's still cool. The issue would be if I had spaces in here or I started a heading with a number or something like that, you would get typically what it says is null in there, which is it's effectively it's an error. It's saying I can't read this. I can't figure it out. There was a number and a space and I got confused. I lost my mind. I don't know what to do. Right? I don't see any nulls in there. That's perfect. That's good. So we got our stuff right here. Now the next thing we're going to do is once we see that in here and we're happy, if you right click on it, come down here to display XY data. And so what this is it's saying, you've got this table and it's got some kind of X and Y, maybe Z coordinates if you're dealing with 3D stuff. Which if it were really important, like the elevation and all that, we could have included that, but it's not. At least I don't think it is for the folks who are doing this work here. But if I was wrong, the Z field would be used here, right? So then you've got to think about, okay, what's my X field, right? Picture an XY graph, right? I don't have anything easy to draw in here, like a whiteboard where I'd be usually doing this in class, but it's the idea. Let's just use this table right here. If we pretend that this is one axis, this line right here, and then this line is another axis right here, right? So our X would be this horizontal one, all right? And the Y would be our vertical one. That's how something like UTM is working, right? So that Y, all right, that's our northing. That's what we're dealing with. Our easting is that X axis. Okay? So we need to tell it that. So the X axis, we want that to be easting. Y, we want that to be northing. And it's okay. If you screw this up, you put the wrong one in the wrong spot, you'll figure it out pretty quickly. When your points that show up here wind up in the Pacific Ocean or somewhere where they just don't belong. So that's a real easy way to check and make sense of it. Okay, so we put that in there. Then this unknown coordinate system thing, we got to fix that, okay? Because we know what our coordinate system is. It's UTM, Universal Transverse Mercator, Zone 11. And this is where we're going to tell it that that's what's going on. And it's, again, remember, computer's not smart. It doesn't know. It isn't like, oh, you guys are working on the Antelope Valley. It's going to be Zone 11, because that just makes sense or whatever. We got to tell it everything. So if I click on Edit right there, go into Projected Coordinate Systems, and the difference between geographic and projected, don't worry about it at this moment. Take a GIS class if you're really concerned. That's where I'll talk about that stuff. UTM. Now I believe... Oh, hell, I can't remember. I don't think they have it here. I did tell these folks which ones to use. I'm pretty sure I said NAD 1983. I might have said, because it's been a while, stuff's been going on, WGS 1984. Hell, I can't remember. I'm going to say NAD 83. All right, I'm going to go with it. If it's wrong, well, we might see it might be pretty obvious here, but this is also, if you're working along, this is why setting up that GPS unit is important, and knowing which datum you're working with and all that stuff. I'm just going to go on a hunch. Hell, I don't care. It's not my project. I'm just going to put this in here like this, hit OK. It populates that. And then I'm going to hit OK. And it'd say, oh, does it have the subject ID field? I say, yeah, I don't care. And we hit OK. And then look at that. My God, I got some points right here. Do you see those show up? And it says these little trash events right there. And it's important to be aware that this events thing, this isn't a permanent layer in here. So it's just kind of a temporary deal. If I want to make this more permanent so I can use it again later, I'll right click on the events layer in here. I'll go to data and export data. This is just the way I've always done this. And I'm going to export it, but I'm going to save it as, either a shape file or a feature class or whatever. Again, this is getting into kind of nerdier GIS stuff. Normally I would, tell students be more deliberate about this stuff. I'm just going to throw it in this generic thing in the interest of time. I'm going to hit OK. Yes, I do. Thank you for asking. And then I'll just turn this off. In fact, I'll just delete it because it's make-believe. It's not useful, but I got these same points. It looks almost identical, except we got this little red color in here. But that's, it's different. It's different in how it's saved. Okay, this gets a little nerdier than like the bio people probably care about, but there you go. Now it's a question of, where are we? If you look at our scale, this is 1 to 22, meaning like an inch on here is 22 inches in the field. That's really zoomed in. Let's do, hold on. Old man with a computer. Hold on. Let me at least do that. I'm out to 1 to 1,000. Now what I'm going to do, just to get a sense of where we are, hopefully this will work out. I'm going to do this add data, hit the drop down, hit add base map, just to get some kind of reference in here. And let's do imagery, just because that's sexier than some of the other stuff. This is exciting. We'll see if it looks like the general Antelope Valley. Oh, that's looking good. And this, okay, it's warning that it's different, right? Because I'm working in that NAD 83. This is saying it's in WGS 84. We're going to say it's cool. I'm going to fully ignore it. Sure, turn this on. Okay, this looks good to me. This looks like the kind of place where AVC students would drive out, right, to look at trash. This is too, if I had a body pillow I needed to dump, this is exactly where I dump it, right? So it looks like, my God, I'm thinking we map this mother right there. Fantastic. Way to go, team. So yeah, there's our, there are points. There's the trash. And just to, let's do this just to make it really stand out, are 2 points right there. And so the idea is, if I went in and with my Excel/CSV file, if I went in here and, took the time to enter this stuff, and I could honestly, as I was saying, let me open this up. In here, I just did the description, the waypoint, UTM zone, easting, northing. That was enough. That's even more than I needed. Really, all I needed was the easting and northing to get it onto the map. The description is useful, so I know exactly what it is. But I could, if I'm thinking forward and I'm thinking about analysis I want to conduct on these points, maybe there are different classifications of the trash that I'm looking at, right? Household goods versus industrial waste or whatever, right? I could have as many columns in here as I want, these different fields, and I can just input that data as I'm putting this table together, right? And then what I can do later, if I want, let's just use, didn't really pay attention in here, but let's just say you've got industrial stuff, you've got household waste, whatever, something along these lines, or hazardous versus non-hazardous, or these different classifications. If you have that, then it's really easy to, as you get all of these points, because right now 2 points, it's not a big deal to sort these things. This isn't really good for analysis, but let's say I have 500 points out here. If I'm inputting the data properly as I'm going through with this, and I'm putting in different classifications and really thinking about how I'm going to study this, it'd be real easy for me to effectively ask the computer, hey computer, you have to type some stuff and click some, you don't actually talk to it yet. But I say, hey computer, show me all of the industrial waste, right? Just that. And you could go in and you could select just that. Instantly, it would take 2 seconds to do that and just see that, right? Or, show me this, show me that, and so on. So as you're doing it, we want to get the easting and northing descriptions so we can map the stuff and know what it is. At the same time, think about what do you want to do once it's mapped, right? Is it just, I want to map it and that's it? Or do you want to analyze it in some way? And if you know what you're doing ahead of time, which like good little scientists, you should have some kind of plan in place, some kind of method you're working from here, right? If you're thinking in that way, you do it at the beginning, it's going to pay off. The work is going to be so much easier, right? So think about exactly what you want to do, but also make sure that as you're putting this stuff together, keep it simple, keep it clean, and if you do that, you'll be able to map the thing. All right? All right. It's been fun. Have a lovely, lovely day.